Thank you and good morning. Good morning, Bergamo. Good morning, Italy. This is not my first time in Italy, though, but first time in Bergamo. And what a beautiful city. So I come from beautiful Toronto, Canada. Okay. And I took an airplane to get to Bergamo. Canada is a beautiful country. And Toronto itself, I consider to be the center of the world. Okay, I'm biased. And it took me around, just on average, 5,615 kilometers to get here. Okay, so it was quite the journey. But today we're not talking about geography, Toronto, or Bergamo. I'm here to present Crawlector, which is a threat hunting framework. So what is Crawlector? It's a combination of two words, crawler and detector. It's a threat hunting framework designed for scanning websites, for malicious objects, primarily compromised websites, famous as CNN, Yahoo, Google, or whatever. And in particular, you must have heard of websites that have been used for waterhole attacks, for example, military websites, government websites, that to be visited by senior citizens or targeted employee. And of course, you've got exploit kits, such as drive-by download type attacks. So Crawlector, what is it like at a very, very high level, in a nutshell? What does it consist of? The framework, it follows these 4 steps. First, you give it a list of domains, and this is the input. Set of YARA rules, and then it goes into searching these domains by spidering the page, /pages, and crawling them. So there is a difference between a spider and crawler, I will explain later. And then detect any suspicious objects on these pages. And upon a detection, it gives you results. Okay, this is at a very, very high level, and then we'll get into the details of what each of these steps entail. So the thought layout consists of the following key steps. First, the motivation. Why did I write this framework in the first place? And Crawler itself, the framework, the features that it consists of in terms of design, architecture, and whatnot. And then it will take a couple of slides to talk about the files and folder structure of the framework, because it consists of a lot of files, folders, and configuration information. And then the site formatted patterns, since the input is domains, list of domains, but it accepts different types of domains. And then some of the limitations, which are design choices, and then experiments to prove the effectiveness of the framework itself, and then a demo if I have any time left. So the motivation, I always wanted to do something like this, or write something like this, just out of curiosity, for no other reasons. And I had the idea of this back in 2018. I was visiting some colleagues in Ottawa, and then I had this idea. I started taking some notes. And by the way, this web stuff is out of my comfort zone. This is not what I do for my job, not even out of interest. I'm mostly interested in reverse engineering, compilers, IPSs. So this was just for fun. And seriously, I was excited about the results before the results. So after I write this framework, what do I get? Would it yield any useful information, or just be, I had fun doing it, that's all? And then I am a huge fan of C++, and I'm sort of deadly allergic to Python or any of these high-level languages, especially that are space or indent-based, especially for scoping. I can't use them, no matter how powerful or feature-rich. So C++, I mean, it keeps evolving, and the standard is highly active, and every now and then they introduce new features. It was perfect excuse for me to write the framework in C++ and experiment with different features. So that was one of the excuses. And at the end of the day, it's an experimental project, meaning it's a fun hobby project. I can do whatever I want with it, whenever and however. So what it consists of? Some of the features. First, it supports spidering. So first, you have to keep in mind between those two words, crawling and spidering. So spidering is restricted to finding additional links on the page that you're scanning. Okay? For crawling consists of actually scanning whatever list of pages you give it, irrespective of being restricted to that same origin page. And it's a design choice that I'm restricting it only to 2 levels only, and this is for performance reasons. You will see later what I mean by that. And it uses Yara, which is you're all familiar with it, as a backend engine for rule scanning. At this point, like when I was deciding, like as part of the design phase, whether to write my own domain-specific language as part of the logic that will go on and detect suspicious objects on these pages, which I did that in the past. But after looking into Yara, especially the C API, I decided to settle on it. And I found it to be the perfect candidate for this job, actually. And I do vouch, I'm not a Yara like developer or anything, just I happen to use it and find it very useful. The C API is actually extremely clean, and it works as expected. So there was no issue with that. So I recommend you to use it in your own projects, so you don't have to reinvent the wheel and coming up with your own domain-specific language. And all the constructs you need in terms of primitives, conditions, or whatnot, Yara has it. So you don't need to do any of the shenanigans. It supports online and offline scanning. By that I mean, of course, you have the real-time scanning of these websites. And as a post-processing, you can save these websites as part of the configuration file, and then you can do post-processing on existing files on the system. So you don't have to query that domain again and again. And of course, as you see later on, supports caching and whatnot. It supports crawling for digital certificates too. So this is important. You'll see later why. You can get the certificate of the domain you're scanning, and at the same time, you can get all the attributes in the certificate, like the issuer, the subject information, the validation, all these attributes, and the public key, the size of the public key, whether it contains a public key or private key. All of this statistical information is important when you reason about what's out there on the web. And as part of this feature, actually, I ended up writing a paper called The State of SSL TLS Certificate Usage in Malware CNC Communication, which is available on Trend Micro Threat Lab. And it supports querying URL house from abuse.ch for finding additional malicious URLs. And of course, as you scan these pages, you can save them locally on your disk and zip, password protected, or whatnot. It's all configurable. More on the features. So there are multiple fuzzy hashing type algorithms, and one of them is TLSH, which is developed by Trend Micro. And of course, you have other standard symmetric type hashing, such as MD5, SHA, SHA-256, RIPE-MD, and among others. So you might think that this is just as simple as hashing the body of the page you're requesting. So what's the point of that? You will see later on like how important this feature is. It's so simple to implement, but it will prove its worthiness later on. So TLSH in particular, on its own, it might not be useful for you as a hash, but when you have, like, you're scanning thousands of domains and you want to cluster those domains, so it becomes a useful feature, especially if you can use like a TLSH own clustering code for finding similarities or deviation from what you're expecting. And of course, you can get domain resolution for IPv4 or IPv6. And even if the same domain is resolving to multiple IP due to load balancing or proxies or whatnot, you'll get the list of all IPv4. And simple feature, but you will get interesting results later on. And the framework itself is proxy aware. All HTTPS communications are proxy aware for different proxies, NTLM and whatever. More on the feature side, and this is something to keep in mind, that the entire framework does not accept any command line. It's all controlled via a single configuration file. It's around, I don't know, like 100 line INI based configuration file. So you have to be cognizant of this feature, and it's full documented, so you don't have to just wander around which feature to enable, which feature to disable. And At this point, I had to decide how to, like after scanning all these websites, running them against GR, everything is in real time, all this information, whatever feature you enable, how am I gonna present this information to you, right? So I decided to settle on a CSV file, which I found it to be like the perfect format. But part of my experience, I suggest that you convert the CSV file to SQL file for better performance and querying. And all the information that are necessary, at least what I think are necessary for you to, for investigation, will be saved onto this CSV file. It's one executable, just one exe. So there is no hellish dependency. So if you're using Python, for example, that's my hate for Python. So you have to rely on, oh, this version. Oh, no, that version. Oh, I need this dependency. Oh, no, it works on Ubuntu kernel version X. No, it's one executable. It runs on all Windows. Again, I'm also Windows biased. So it's written in C++. It's this many number of codes, and it's evolving. Now onto the files and folder structures. The CL sites file, folder, I should say, this is where you give it the list of domains that you want to scan. And of course, it supports multiple files and directories. The name is not specific on anything. Crawl, so as part of the spidering feature, so as you're crawling a certain domain for finding additional links, be it external, internal, or whatnot, depending on the configuration, those links that it found, they will be saved into text files, so if you want to scan them later as well. The list of certificates, of course, if you want to introspect those certificates later on, they will be saved in this directory under the dir format. Results, of course, this is where you get your pages saved. The content itself, excluding any headers. So PG cache, so you have two types of caches. The program cache as well as the spider feature cache. And this is important to keep in mind. So the program cache, this is specific to the page itself. Okay, so as you're scanning the page, you can save it locally as it is, or you can save a cache of it. Why this is important? So in case you're scanning the same page again, instead of making a request to the page in case it didn't change on the server, you've got a local copy. So the framework itself would load the local copy for you. This is depending on whether you enable caching or not. The CL cache, this is for the spidering. URL rule, this is where you give it your list of URL rules. Now keep in mind, you don't have to use URL to validate the rules. The framework itself would load all of your URL rules, parse them, validate them prior to any execution. Now, this is the important file. It's clconfig.ini. So this is pretty much the orchestrator for the entire framework. And the only command line is V, which is version information, okay? Now, the logs, like the results of the scanning, is saved per session, okay? According to this file format. It includes information such as any URL rule that I've triggered, the offsets where it triggered on the page, the length of the trigger, HTTP, list of HTTP headers, hashes, the LSH hash, the URL itself, ID, URL house. And that one, the CLM log, this is for online scanning, okay, meaning real-time scanning. And then in case you want to scan existing files on the system, it will create another session file called offline logs. And this contains less information because, of course, if you're scanning something local, you won't be able to query some of the information such as the server headers and whatnot. And of course, you get another log file for the search. This is standalone log file containing information specific to every digital certificate attributes. And now here you have to keep in mind that if you enable the certificate feature, it's mutually exclusive with respect to the rest of the framework's features. So when you enable this feature, only this feature will work. Okay, and that's a design decision. Probably I will change it later on. So first we'll start with one of the features supported by the framework, which is URL house scanning. So what is URL house? So this is a list of domains, malicious domains, provided by abuse.ch. Okay. So as you're scanning a page, the framework will query this URL house server, get this list of domains automatically for you, which at this point of time, it contains around 113 million entries. So you can tell how expensive it is to scan every page with those. And then in case of a match, it's going to query URL house server for additional information on this query, on this detection. For example, on a domain X found on this page, this domain belongs to malware X. It is of this type, and it falls under this phase. For example, if it is post-compromise or pre-compromise, it gives you all this information and, of course, gets populated in the log file. And in case you don't want to query URL house, like the server, you can also give it a URL house file local to you, local to disk. And you have to keep this in mind, that this feature is extremely expensive. I mean, if you're scanning 1,000 page, imagine. Every page will be scanned against 113 million entry, okay? Whether you're using the most powerful search algorithm or whatnot, it's still an expensive feature. Now, we come to the sites format pattern. And this is probably one of the core features in terms of the input. And it supports 3 types. The easiest one is type 1, which consists of 1 domain per line. You don't have to give it an ID or anything. Just give it the domain as it is, okay? Irrespective of the protocol or any URL appended to the top-level domain. And of course, the framework itself will assign a unique ID to it. Again, derived from the host name. So that there's some work involved in how the ID, so that it is self-descriptive just by looking at the ID, so that you can tell to which domain it belongs to. Type 2 is where you give it your own ID, okay? And you can, like here, again, this is a design decision. I decided that you are allowed to give it multiple IDs, like the same IDs for the same domain. But during evaluation, the framework will assign a unique ID as well. So there's no collision involved at this point. Type 3, this is specific to the spider functionality. And this is something that you have to understand a bit more. It has this format. So the ID follows the same type 2 ID format, consists from this regex. But between those brackets, you've got these 3 conditions: depth, total, and sleep. So let's take this as an example. So let's say I want to scan mfmokbel.com or nohat.it, right? So you want to find additional links on this website. How would you do that? So first you start in the middle with the total keyword that takes a digit. So you say, find me a max of 10 links on the domain you give it, mfmokbel.com, or it could be any other subdomains, okay? And then between every request, sleep for X number of milliseconds. And in case depth is enabled via the value 0 or 1, let's say it's enabled, it takes the value 1 in this case, depth 1, and then it takes the value 3. So out of every page you found in the total, find me additional 3 pages. So best case scenario, you will have 40 links found. This is best case. Why? First, you have the base 10 that you found on the page you're looking for. And then off of every one, find me an additional 3. Thus, 40. And you might be wondering, can I go like in depth higher than that? Like even after finding those 10, and then find me 3 on each one of them. You will find additional links, right? I mean, the depth never ends, but it's a design decision to stop at depth 2. Okay? The framework is meant to be simple, and it's not meant to scan the entire web. Now, as part of the features, let's say you're using type 3 URL, but you want to use it as type 1, right? So you don't want to redo some of the work just to turn it type 1. I'm not talking here about one URL, in case you have thousands of URL in the list of input. So this is in the configuration file. You can set a simple option to false, and then you've got type 1 URLs. And of course, it accepts comments and whatnot. Now, for the spider functionality itself, it has some specific features. And these are important, especially when you're scanning for web skimmers, or you're looking for something specific on that page, right? You don't want to just collect whatever is on that page, right? So you can influence that behavior via these specific configuration options. So for example, you say, on this page that I'm scanning, as you're finding additional links, exclude all links that ends with, like it accepts wildcards, zip, exe, and whatnot. You're not interested in this stuff, okay? Or include URLs that only contains checkout or products keywords in them. Why this is important? Perhaps your URL rules are scanning only for web skimmers. And web skimmers target checkout type pages, right? So you're restricted to that type of stuff you're looking for. And probably you're not interested in HTTPS type URLs. You can configure it as such. Probably you're only interested in external links on that page. Why? Perhaps you have an iframe that is pointing to a server that's not part of the domain you're looking for. So this might be suspicious. It need not be, but it depends on what you're looking for. And again, you can restrict it to external links only. FODME, nothing but external links on that page. So it looks it's all nice and whatnot. Perhaps you get the impression that, oh, it does a lot of stuff. But of course not. There will always be limitations. Again, those are design decisions. Some of the limitations are it's single-threaded. Why? Not because of technical limitations as much as it's a choice. When I started it, it's meant to be like a simple project. But as I started adding features, I realized, oh, some of the stuff definitely should be multi-threaded at this point in time because it's taking a lot of time to scan some of the stuff. And the more features you enable, the longer it takes. So at this time, first release, it's single-threaded. Keep that in mind. But I am working on multi-threading, like the spider functionality and some of the other stuff. The other key point is that it's static detection, meaning if you're expecting the framework to evaluate some JavaScript that have like malicious, not malicious, depending on the evaluation, it doesn't do that at this point in time, right? Everything is literally based on the URL rule you give it. It's simple static-based detection. So there is no dynamic evaluation of a given page content, okay? But this is stuff on the pipeline to add, actually. So far, I don't find it to be hard to add, even though like it is in C++ and not Python, considering how huge is the Python ecosystem in terms of leveraging other people code. But I found this one to be actually easy to implement too. Of course, no headless browser support yet. Okay, if you don't have dynamic evaluation, you're not going to have headless browser support. Okay, so the framework itself, that's it. Okay, but as you can tell by now, the framework, I mean, yeah, that's fine. I have this framework. Anybody else can write it too. But it is as good as the URL rule you give it. What is the point of having all these features if you don't have the intel to detect these malicious objects on the web, right? And I started asking myself, how can I get this list of URL rules? If you go on GitHub, you go on Google, you search, you will get a list. But some of them, they are written in specific formats. Some of them are proprietary. I mean, my daily job consists of working on IPSs, right? Intrusion prevention system. And we have our own proprietary language for that, right? So I can give you these rules. I cannot give you these rules. And if I want to use them in the framework, I would have to translate them in one way or another, okay? So one of these rules that are extremely important, but yet extremely simple, but powerful. They are part of EK Fiddle. EK Fiddle is a plugin for Fiddler, You must have heard of it. It's a proxy tool for capturing web traffic. You can reissue the same request, just like Burp Suite. But it supports its own rule formats on a line-by-line basis, and they have their own format. Okay? They are so simple yet very powerful. I keep repeating this. I can't stress this enough. You will see later. And I ended up writing a transpiler that would take these rules and convert them into Yara rules. Okay? And EKFiddle itself, the plugin, provides a link on GitHub that would contain these rules under a file name known as master regexes. Okay? And I'm going to make this tool available on GitHub too, just right after the talk, if not during the talk. Okay, now it's available. I just have to make it public. Now it's private. Okay. The tool, I mean, I don't have all the documentation here in the slides, but it's fully documented on GitHub. You can influence the generation of these rules whichever way you want. And this is one of the transpilers I wrote. I wrote another one, but this one, unfortunately, I can't release it. It's specific to my job, but I needed to leverage existing intel that we have in the format that I'm interested in. Funny enough, like this is a bit of transgression here, that the redacted to Yara rule took me more time to write more than the framework and the EKFiddle to Yara transpiler, because it's much more convoluted and involves lots of corner cases on logic. And another thing to keep in mind, like this just for the curious, when it comes to parsing existing regexes to be used with Yara. So Yara, starting with version 2.0, they adopted their own regex engine. They don't rely on standard engines such as PCRE. So, and Yara doesn't use all the interesting features in any regex engine. Okay, so you have to account for those discrepancies. So if you happen to find a regex online and hoping that it will work with Yara, I mean, change your mind on that. Okay, and but the transpiler itself will massage the regex such that it works with Yara. So it parses the regex for you, change it accordingly as best as good, so that it works with Yara. So that's another nice feature. So we'll take as an example one of those rules used by EKFiddle. And as you see in the highlighted one, you got the first, it starts with the type, source code, and then the rule name, in this case, web skimmer, Google Exfil, and then the logic. The logic is in light yellow. It's a content match. It's very basic, right? It's replace image CVV, and then you get the comment optional, which is like Twitter, whatever, whoever is referencing this logic. See how simple it is? You might think this will cause a lot of false positive. It wouldn't detect anything interesting, but look at it, right? You wouldn't imagine that this would yield any useful results. You will see later on that this proves the opposite. And then rule type contains other rule types, such as it's a source code. It's part of the source code, as in the body of the page you're scanning, or it's in the URI, or it's an IP, or it's a part of the headers, be it in the request or the response, or it's a hash of the page itself, or it's an extract skimmer, meaning it's skimmer specific, or extract phone, as in like parsing a phone number, or CMS for any content management system. So for CMS, the rule changes slightly, as in if you're checking, for example, WordPress sites, right? So the rule expects a digit such that find me 10 entries of this same content match on this page. And if you get a hit on that, then not only that, you're sure that you're doing with a CMS system, okay? And also the transpiler accounts for this rule type. So we'll take this rule as an example and feed it into EKFiddle to your transpiler and see what it gives us. It's that simple. This is what you get. First, you get the rule. It massages the rule name and appends to it this random number, because in case you have multiple rules under the same names and you don't want to end up with some collision, it appends this random number to it. So just keep in mind that a random number will change every time you run the tool, okay? And then this is it. What matters here, other than the metadata, is the strings, which is always one condition. And of course, you can tell it to add no case, ASCII, wide, basics for, and whatnot, okay? Just keep in mind about the simplicity of this rule, okay? So it just proves the point that you don't have to innovate too much and go out of your way to come up with some exciting, sophisticated rules just to find something interesting. And thanks, of course, to all the people who wrote these rules and made them public, actually. Experiment. So at this point, I'm done with all this. I got all the rules. I wrote the framework. Now what? Do I sit and wait? So I have to start scanning some websites that I might find interesting. So first I decided to get a list of top 700,000 Alexa websites, supposed to be famous, known, and then additional 100,000 WordPress websites. Why? Because it's known that WordPress are easy to compromise, lots of bugs, lots of vulnerabilities, right, Luca? So you will happen to find a lot of stuff on WordPress sites. And of course, the most important one is Magento CMS sites. So I decided to grab the top 127,000 websites. In case you're wondering from where I get this list, especially for the Magento websites, it's from a site called Built With. It's a very famous site. And it has a lot of metadata about each of those websites, like how much money they make, some of the features they have enabled. So they are really top sites, and they are money-generating machines. So these websites being compromised is a huge deal, actually. And just speaking like this for Giovanni about cryptocurrency, just out of curiosity, I don't even include this in the stats. Well, like, still at this point, I still found like 2 websites compromised with CoinHive. At one point in time, it used to be famous for mining cryptocurrency legitimately, right, by these 2 guys. Funny enough, 2 websites still have it, but according to public www site, there's still around between 700 and 800 sites compromised with this script. Now we go into the actual experiment, and this is where the fun part starts. For example, if you take this usegame.me website, funny enough, the home page is compromised with a web shell. And as you can see in the script here, like between the text area, you can see that it's expecting a parameter command, and it uses the system shell command to execute the command on the system. It is as simple as that, right? You don't need to write a complex rule to detect stuff like this. So some of the other stuff, here I don't go into details about the actual injected code, because that's pretty much irrelevant. You can find a lot of information about this stuff online. But I want to prove the point that it is detecting stuff with X number of counts on different websites, okay? For example, this rule, the redirect malicious RE chain, it is detecting malicious stuff on these 3 websites. And funny enough, probably they all belong to the same threat actor, because the injected code, as shown here, is the same on all 3 websites. So the injected code is pretty much whatever this website points to. And then the same goes for the other URL rules. Redirectors, web skimmers, and whatnot. And more on web skimmers. And the interesting one here for the hex web skimmer rule, which like how many? 3 websites. The one in particular is you've got this total bodycare.co.uk. I don't know what happened at this point. It's a Magento site. It's part of the top 700 Alexa websites. The code is injected, the malicious code is injected twice. I don't know why. Perhaps the threat actor made a mistake or whatnot. It's functional, but it's injected twice. And keep note of this one, the image web skimmer of this website called azcosplay.com. It's some Japanese website. And keep this in mind for now. Sorry for that, but you have to keep in mind about this path. Media5 icon bad bing.png, okay? The funny part is I scanned this website a long time ago, and I visited recently again. So the injected JavaScript code on the page is no longer there, but the PNG image is still there, which contains, it's like the actual malicious JavaScript is appended to this page, to this image, okay? It's still there. Looks like they did not intentionally clean the page. Probably they reverted some other version or whatnot, but the malicious code is still there. It's not functional because it's dormant in this PNG file. It needs a script to load it, but it's still there. Now you might be wondering, okay, so you find all of these, perhaps you might have come across some false positives. It can't be all that glory. Actually, it all depends on the rule you give it, right? And I do happen to have some false positive. And to my surprise, it's one false positive, actually. It was on one of the rules that's supposed to match against some Chinese threat access JavaScript code, which turned out to be not the case. It's just one false positive out of scanning thousands of websites. So I think it is good. More on the experiments, like some other statistics. Sorry, again, for the false positive, there's another one for Spilevo exploit kit. So you've got two so far. I'm gonna skip through this. It's just some stats for your own reference. I want to focus on Magento, because Magento seems to be a big deal nowadays. I'm pretty sure you're familiar with Magento, just like WordPress and some other content management system, but Magento is just primarily like for payment stuff, like Square and whatnot, similar, in the similar arena, especially for checking out, you're buying product, you're entering your credentials and whatnot. It's these pages that you have to keep in mind. So the scanning for these top, not 127, it depends on what's active at the time of scanning, started like between July of this year, July 29th, and ended August 7th. Okay, this is how long it took to scan all of these sites. So it's very recent. So in total, it took about 10 days to complete. And most of the stuff that I'm looking for, they are web skimmers. The number of active websites are 104,000 out of what 127,000. And in total, you get 20 distinct JARA rules fired against 139 sites. And only one false positive. And I'm gonna skip through this and then go into some of the use cases. So you've got 26 websites infected with this particular JARA rule. Again, it's part of MageCard, a web skimmer campaign, with the same code snippet, which implies that it's highly likely it's the same threat actor targeting these 26 websites. Except for one domain, which is haircube.com, which we'll come to it later, which is detected by another JARA rule, but it's still web skimming. The WSS stands for Secure WebSocket, meaning that the JavaScript that's being injected communicates over Secure WebSocket. And then take as an example like for the anti-sandbox rule, like this is one of the JavaScript code injected into the page, which decodes to this page, to this code, points to the main.js, which is the actual malicious code supposed to do actual skimming. And then the WSS case for the haircube.com, this is the code that's being injected, which decodes to this one. So as you can see, it's pointing to an existing load.gif image on the compromised website, and it reads the JavaScript code from the end of the image using the slice method with the negative index and calling it. So it's hiding the code in a legitimate looking image. Like these are some of the websites that are compromised with this rule, and they're all famous websites actually. And at the end of the table, you can see the an image of that, like a logo of that image residing on the system. Here, one thing to keep in mind is point 9. Like you see I'm not sure if the threat actor made an error or whatnot. I don't know what happened at that point. The path actually doesn't exist. Like this path doesn't exist on the compromised server, nor the file name. So yeah, I've been told that my time is over. Unfortunately, there's still more to cover. But it is what it is. I hope that you will get the time to go through the slides. There is more about the experimental stuff. So again, more on what it found here. Like bomb skimmer, you've got these, like the top 4 websites, those part of the same threat actor since they are pointing to the same exfiltration domain. Just more skimmers it found. Just here, like just one interesting case, like for detecting malicious stuff on domain number 3, dileza.com, the injected code was commented out. It's a malicious code, but it was commented out on the page, which I don't know why. And the same goes for 4. The 4 stands out a bit more because the injected code was attempted to be injected twice, whereas in the second time, just a snippet of it was injected, not the whole code, as if the threat actor was, I don't know, asleep at that point in time, drunk, or I don't know. Again, more on skimmers, just to prove the point that it found stuff. And this one is specific to that it uses WebSocket secure protocol. It compromised these 2 websites that belongs to business and industrial sector. And this is funny enough, they use the same exclusive or key and other rules, statistics. General stats, I mean, I will take some time, I'm sorry about that. I'm gonna skip through this one, but this one I have to take some time on it. So just going back to the hashing of the page itself. So in total, you get 1,328 unique hashes. Remember, we're scanning 104,000 Magento websites. And how come we have only 1,328 unique hashes? Right? You would expect 104,000 unique hashes of the page content, because some of them all belong to the same primary domain, right? So this gives us like a key point here that the detection ratio is not against 104,000 pages; it's against 1,328 pages. Okay, so you found 139 malicious website out of 1,328 websites, and of course you get some notes about what each of those hashes represent in terms of like the number of count. I'm going to skip through this one. Some other stuff. Some of the libraries I used. References. Thanks to Jerome Isigura from Malwarebytes for providing these rules. Sakuri blog for documenting lots of these web skimmers. Sensec Research, Risk IQ, Group IP, and various other people on Twitter. Of course not. You're not going to get a demo. Conclusion? I guess you have to draw your own conclusion by this time. And thank you.